Okay. Hi everyone. So, how is your break? You have a good rest? So, I have read your exam, but I haven't summarized the mistake yet. So, I will give you back the exam on Wednesday. Okay? So, uh, today we are behind schedule. So today we will continue to talk about session 7.2. And and then so because we're behind schedule, so we might not have a class time for review, but I will also do the 2 hour review session. Is Wednesday okay for you? Yeah, so you can see our exam is on the Monday. So and it's cumulative. So I hope you can like start reviewing your previous notes, okay? And for the homework, if you miss some homework, please submit your homework. I still collect your homework. And for those of you who didn't submit your practice exam or exam record or corrections, you can still submit those. The last day I accept all the late work is on the Friday, December 9th. Okay, that is the absolute deadline. Because then over the weekend I will calculate your grade, and once I have your final exam scores, I will post your grade on next day. So you submit everything except your practice final exam. The practice final exam is due on the 5% dates. Okay, everybody? So on the website, at the very bottom, do you see this final formula sheet? Okay, so this is the final formula sheet. Where is it? Oh, here. Okay, so it has everything we had before, plus these formulas. So somewhat different formula, and we have cosine, sine, and tangent. So that is in section 7.2. And then in section 7.3, we'll talk about double angle formula. Section 7.4, we'll talk about product to sum formula and sum to product formula. So for all these formulas, you don't have to memorize. You just know which one to use. Okay, everybody? And also in chapter 8, we'll talk about the law of cosine, and the formula will be given as well. Okay. All right, and this sheet is at the bottom of our website. Okay, so on the final exam day, I will print it out for you. Yeah, right. Okay, so let's see. Let's continue. So last time we talked about the sum and difference formula for cosine, sine, and tangent, right? And so we did part A and part B. Now let's do part C. Okay. So first of all, tangent 11 pi over 12. So 11 pi over 12. This is in which quadrant? Quadrant 2, right? Everybody? Yes. So quadrant 1. Okay, so how do we know? So 0, let me use a different color. Okay. So 0 to power 2, that is quadrant 1. And then power 2 to pi is quadrant 2. And then pi to 3 pi over 2 is quadrant 3. And then 3 pi over 2 to 2 pi, this is quadrant 4. Right? 11 pi over 12. This is slightly smaller than pi. Right, everybody? So that's why this angle is in quadrant 2. And this is theta. How do we find the reference angle? Remember for quadrant 2, this is theta. And then theta prime. The reference angle is the angle made by the terminal side and the horizontal axis. Right, everybody? So in this case, do you see they are supplementary angles? We add them up together, we get 180 degrees, right? So therefore, theta equals pi minus theta prime. So therefore, tangent of 11 pi over 12, that is tangent of pi minus, so you see 11 pi over 12 is pi minus pi over 12. Yeah, because 11 over 12 is like 1 minus 1 over 12. Is that okay, everybody? Mm-hmm. Aha. And then this equals plus or minus, okay, tangent of pi over 12. But plus or minus, it depends on quadrant 2. Your quadrant 2, your tangent is positive or negative? Negative, because it's quadrant 2. Therefore, we pick the negative. So it's negative tangent pi over 12. Yes, everybody? So this is how we can find the reference angle. Okay. And once you get to pi over 12, related to our common angle. Our common angle are 0, pi over 6, pi over 4, pi over 3, and pi over 4, and pi over 2. Right, everybody? Those are the common angles. So we first make this to the reference angle. Pi over 12 is what? 15 degrees, which is like 45 degrees minus 30 degrees, right? So which is pi over 4 minus pi over 6. Yes. Or you can use pi over 3 minus pi over 4 because it's also 60 degrees minus 45 degrees. Yes, everybody? Which one do you want? Pi over 3 minus pi over 4 or pi over 4 minus pi over 6? First one, because it looks like the power 3, the denominator, is easier than power 6, right? So, okay, this is negative tangent pi over 3 minus pi over 4. Aha. So now we can use the sum and difference formula for tangent. Bless you. So what is that? Tangent, see? Tangent, see? Okay. Tangent. A minus B is tangent A minus tangent B over 1 plus tangent A times tangent B. So tangent A, okay, so negative. This negative stays here. And then we have tangent A minus B is tangent A. A is pi over 3 minus tangent B. B is pi over 4. Okay? And over 1 plus tangent A times tangent B. 1 plus tangent A times tangent B. Yes, everybody? Okay. Now, what's tangent pi over 3? Okay, so tangent pi over 3. What is that? Okay. We need a formula, right? Pi over tangent pi over 3 is root 3. Yes, everybody? And minus tangent pi over 4, which is 1. So root 3 minus 1 over 1 plus root 3 times 1. Is that okay, everybody? So we first. Okay. So, yes. Attendance. Yeah. This week is the 15-week Monday, right? Okay. Yeah, we start with this is not in the first quadrant, then you need to look at the reference angle. Okay, so this is in quadrant 2. That's why our reference angle, theta equals pi minus theta prime. Theta prime is pi over 12. And we know second quadrant, the tangent is negative. And then once we get an acute angle, we know, oh, pi over 12 is pi over 3 minus pi over 4. Then we can use the sum or difference formula for tangent. Right, everybody? And then these are the common angle value. You know those. So look at the table and figure out these numbers. So this is our answer. Okay, everybody? So if the problem wants you to simplify your answer, then what you do is, okay, so this is 1 plus square root of 3, right? What do? You can multiply by the conjugate, which is square root of 3 minus 1. The good thing about it is now your denominator is like a plus b times a minus b. That's a squared minus b squared. So your a is like square root of 3. The b is like 1. So a squared, it becomes square root of 3 squared is 3. Minus b squared. 1 squared is 1. And then your numerator is square root of 3 minus 1 squared. So a minus b squared is a squared minus 2ab plus b squared. So your a is square root of 3. Then a squared becomes 3. Right, everybody? And minus 3 minus 2 times square root of 3 times b is 1, plus b squared, 1 squared is 1. So you get negative 3 minus 1 is 2. Numerator, 3 plus 1 is 4. 4 minus square root of 3. Therefore, we can divide it by 2. You get 4 over 2 is 2. And 2 over 2 cancel. And if you want to get rid of the parentheses, you get minus 2, and then minus negative become plus square root of 3. So this is what we can simplify it. Okay? If the problem doesn't ask you to simplify your answer, you can stop at this step. But if the problem asks you to simplify your answer, that means we don't want to have like square roots in the denominator. Then you can multiply by its conjugate to get rid of the square root in the denominator. So rationalize the denominator. Is that okay, everybody? All right. So yeah. So part A, we use the sum or difference formula for cosine. Part B is the sine. Part C is the tangent. Now we have used all 3 of them. Part D. Part D is like the opposite, right? We have the, okay, look at this format. Cosine plus sine. Cosine plus sine. Which one? Cosine plus sine. Yes, do you see this formula? It equals to cosine A minus B. So this is the reverse order, right? Look at the pattern, cosine plus sine. That is the cosine A minus B. So this is the cosine A, 173 degree, minus B, 83 degree. What is 173 degree minus 83 degree? Oh, 90 degree. Thank you. What's cosine 90 degree? Okay.
Yeah, cosine looks like that, right? At 90 degrees, it is 0. Are you okay with that, everybody? Remember your cosine and sine? So they are waves. So the cosine start with 1. And here at pi over 2 is 0. And at pi is -1. And 3 pi over 2 is 0. And at 2 pi is 1. So therefore 90 degrees pi over 2, that is 0. So far so good, everybody? Okay, good. Oh, for those of you coming late, don't forget to watch the recording and write down the notes you missed. And the last week of classes, okay, which is, yes, the December 9th, this week, you can give me a note and then you will receive 1% bonus. You get 1% attendance bonus if you miss no more than 2 classes, and you have the notes taking bonus. But make sure you don't miss any problem, because if you would miss one example, you lose 0.1. So if you miss 10 examples, you don't get any bonus. Okay, so if you miss a day, make sure to write down your notes. Okay. Yeah, so if you take your notes on your iPad, then you can show me your notes through your iPad, right? Okay, so let's continue. Number 2, find an angle theta that satisfies each of the following. Okay. Function and cofunction. What's the relationship? So here we're using cofunction identity. So sine, cosine, they're cofunction. So that's why this angle, complementary angles. Right, everybody? Yeah. So therefore, secant, secant and cosecant, they are cofunction. Right, everybody? So that equals to secant, complementary angles. What's 90 degree minus 62 degree? 28 degree, right, everybody? That's why the problem says find an angle. So we can let theta be 28 degrees. So there are more than one answers, okay? You can like add 360 degrees to it is to another angle, satisfy the following. But the easiest is we let theta be 28 degrees. That's the easiest. Okay? Tangent and cotangent, they are complementary angle, right, everybody? So we got, this is tangent 90 degree minus negative 54 degree. And what's that? Minus minus become plus, right, everybody? So, ooh, that is 144 degree, right? So we can let theta be 144 degree. So that's the easiest. So far, so good, everybody? Yes. So cofunctions in the angle are complementary angles. Yes. So this is problem 2. Everybody understand problem 2? Any questions so far? All good? Okay. All right. The following problems are examples of reduction formula. We write cosine 90 plus theta as a trigonometry function of theta alone. So here we're using the sum and difference formula. Cosine an angle plus theta, which is, see, cosine an angle plus. So which means we're using this formula, cosine A plus B. Right, everybody? So cosine A, cosine B, minus sine A, sine B.
Okay, so cosine A, which is 90 degree, times cosine B, which is theta, minus sine 90 degree times sine theta. Is everybody okay with that? We are using that formula. Cosine A plus B is cosine A, cosine B minus sine A, sine B. Right? Everybody? So okay. What's cosine 90 degree? 0. So cosine theta minus, what's sine 90 degree? 1. Oh, you see? 0 multiplied by anything is 0. So we get negative sine theta. Yes, everybody? Yeah. So we get cosine 90 degree plus theta is negative sine theta. Okay, how about sine 270 degree minus theta? Here we're using the formula
Sine A minus B is sine A cosine B minus cosine A sine B.
Yes. By the way, all this formula will be provided in the final exam, so you don't need to memorize it. But you need to know which one to use. Okay? So sine A minus B is sine A cosine B. So sine A cosine B minus, right? Cosine A sine B. Okay, one is sine 270 degree. So 270 degree is what? 3 pi over 2. Yes. So sine of 3 pi over 2 is negative 1, you see? So this is negative 1 cosine theta minus, what's cosine? 3 pi over 2. Yeah, cosine 3 pi over 2 is 0. Right, everybody? 0 times sine, oh, sorry, not B, theta. 0 times anything is 0. So the answer is negative cosine theta. Is that okay, everybody? How about tangent 270 degree minus theta? Wow. We're going to use the tangent formula, right? Tangent A minus B. Aha.
Tangent A minus B, tangent A minus tangent B over
1 plus tangent A times tangent B. Okay, so that's tangent A minus tangent B over 1 plus tangent A times tangent B.
By the way, here, because it's only one angle, so whether you put the parentheses or not does not matter. But if you have like this expression, you must put the parentheses because that means the minus theta is inside the angle. Okay, everybody? But if you only have one angle, then it's up to you whether to put the parentheses.
Okay, tangent. Oh, tangent graph looks like what?
So sine, cosine, wave, tangent, like x cube, like x cube, right? So like that. Cotangent, decreasing function. And secant, cosecant, up, down, up, down. You remember that, everybody?
So tangent.
Where's my pen? Wait. You should take this. Thank you. Okay, so yeah, tangent looks like that. And this is pi over 2. And then, oh, here, that's 3 pi over 2. Oh, we get stuck because that is undefined. So this is undefined. Okay? So we get stuck here. Does that mean we're not able to calculate that? And the answer is no. It just means that we cannot use the formula of tangent. It doesn't mean that we cannot calculate that. So what we need to do is, okay, tangent is sine over cosine. Okay? So this only means that we cannot use the tangent some different formula because the tangent 3 pi over 2 is undefined, right? You cannot put in an undefined here. That gives you nothing, right? So we cannot use that formula. Then we use tangent is sine over cosine. Okay? Sine over cosine. Well, what's sine? Hey, part B, we did that. Sine 270 degrees minus theta is negative cosine theta. Yeah? This is from part B. We get that. Save us some work. How about cosine 270 degrees minus theta? Well, cosine A minus B is cosine A minus B, cosine A, cosine B plus sine A sine B. Yes, everybody? Yeah? Cosine A minus B is cosine A cosine B plus sine A sine B. So cosine A cosine B plus sine A sine B. Is that okay, everybody? What's cosine 270 degrees? 0. See, cosine 270 degrees is 0. What's sine 70 degrees? 270 degrees? Negative 1. Oh, you see, 0 times anything is 0. So we get negative cosine theta over negative sine theta. Do you see negative negative cancel? What's cosine theta over sine theta? Cotangent theta. Oh, what does this problem tell us? It tells us sometimes if we cannot use the tangent formula, you can express it in terms of sine and cosine. Use the sine and cosine somewhere different formula, and then simplify it. Is that clear, everybody? Because sine and cosine, the domain is all your numbers. But for the tangent, you have those vertical axes. We cannot put in undefined. Okay, everybody? Yeah. It just means you cannot use the tangent formula. It doesn't mean that we cannot continue and solve the problem. So express to sine and cosine. All right. Okay, so number 4. Suppose cosine S is 15 over 17 and sine T is negative 24 over 25. And that S and T are both in quadrant 4. So quadrant 4. Find cosine S minus T. Cosine S minus T. So first of all, let's figure out what is that. And then we know what we need. Cosine S minus T, we
we use the cosine A minus B, right? But now it's cosine S minus T. So A is like S, B is like T. So that's cosine S cosine T plus sine S sine T. Yes, everybody? Mm-hmm. So we compare which formula to use. Cosine and the different formula. So cosine S, cosine T, and then plus sine S times sine T. So far, so good, everybody? Okay. So cosine S. We know cosine S, see? Cosine S is 15 over 17. Cosine T, we don't know it yet. So we need to figure out what's cosine T. Sine S, we don't know it yet. So we need to figure out what's sine S. Sine T, we know. That is negative 24 over 25. Right, everybody? So we need to figure out what is cosine T and what is sine S. Okay, what's the trig identities involve sine and cosine? What's the trig identity involve sine and cosine? What is that? Yeah, very good. So sine squared plus cosine squared equals to 1. Therefore, if we know the cosine, we can figure out the sine. Okay, so sine S squared is the 1 minus cosine S squared. By the way, this theta can be anything. So the theta can be S or it can be T. So we know the cosine and we're looking for sine. That's why sine squared equals 1 minus cosine squared. Is that okay, everybody? So cosine squared, cosine S is 15 over 17 squared. So that is 1 minus 15 squared over 17 squared. Common denominator, 17 squared. Well, then it's 17 squared minus 15 squared. Can you tell me what that is? What's 17 squared minus 15 squared? Use your calculator. 64. Thank you. All right. And then, so this is sine S squared. We're looking for sine S. So sine S, you get plus or minus square root of 64 over 17 squared. That's the reason I don't multiply 17 squared. Because I know the square and square roots will cancel. So you get, oh, by the way, what's square root of 64? 8. And the denominator is 17. Right, everybody? Now, do we pick the plus one or the minus one? Look at S. S is in quadrant 4. The quadrant 4, your sign is positive or negative? Negative. So S is in quadrant 4, so the sign is negative. So then we know the sign S is negative 8 over 17. Sign S, negative 8 over 17. Is that okay, everybody? And then we use the similar method to find the cosine t. Okay, so cosine t. Yeah, if you want to solve a cosine, cosine squared is 1 minus sine squared. Right, everybody? So cosine square is 1 minus sine square. Sine t, negative 24 over 25. By the way, square, negative 1 square is 1. So you still have the minus. So you have 24 square over 25 square. That is 25 square, and then 25 square minus 24 square. What is that? What's 25 square minus 24 square? What? 49. Ooh. Good. Cosine t is plus or minus square root of 49 over 25 square. What is square root of 49? 7. And the denominator, leave it as 25. Do you see that is why I don't multiply 25 squared? Because the square cancels the square root later. So that's why I leave it like that. T. T is in quadrant 4. Your cosine is positive or negative? Positive. Aha. So cosine t is 7 over 25. So 7 over 25. Oh, now you see our denominator, 17 times 25. And then here, 15 times 7. Do you see negative cancel? So we get 8 times 24. What is that? Plug in your calculator. What do you get for your numerator? 297. What do you get for your denominator? Thank you. Yes. So we finished this problem. Okay. So first of all, cosine x minus t. Look at the cosine difference. And then, oh, we know cosine s, but we don't know cosine t. We know sine t, we don't know sine s. Then find them. What are the trig additive in like sine and cosine? Sine squared plus cosine squared. But when you use the square root, you get plus or minus square root. So you gotta be careful with the angle in which quadrant. And you know, oh, it's positive and negative. Okay, keep going. Problem 5. Cosine, arctangent. Okay? Arctangent. Oh, so if you see the inverse trig functions, call them to like angle. Okay, so like our exam problem, we let theta be the inverse trig function, right? And then figure out what is the trig function of that theta. So here, what do? We call this as A, we call this as B, and then this is like cosine A plus B. Do you agree, everybody? So cosine A plus B is here. Cosine A, cosine B minus sine A, sine B. So that's cosine A, cosine B minus sine A, sine B. Yes, everybody? Right? Okay. Now what do we do? What's cosine A? Okay, so let's figure out what is A. So A is arctangent 1. Oh, by the way, arctangent is the same as tangent inverse 1. This means tangent of A is 1. Is that okay, everybody? So you draw the triangle. So
Now this angle is A.
Tangent A. What's tangent? Opposite adjacent hypotenuse. What over what?
Yes, opposite over adjacent. Well, that means your
Opposite, because 1 is like 1 over 1. You can let your opposite to be 1. Your adjacent is also 1. Then
what is the hypotenuse? Square root of 1 squared plus 1 squared. Yeah, by the Pythagorean theorem. So this is square root of 2.
yes, everybody?
Aha, so
Cosine A. What's cosine A? Adjacent over hypotenuse, right? So your cosine A is 1 over
root 2. Yes?
How about your sine A? Opposite over hypotenuse, right? Which is also
1 over root 2. Right? And by the way, we haven't finished yet. I just leave some space there. Okay, let's use this color. And we still need to figure out what's sine B and cosine B. So what is B? See, B is at cosine, well, which is the same as
cosine inverse x. Yeah, everybody? So that means what?
cosine B is x. Is everybody okay with that? Yeah? So now we draw the triangle. Now this is B. What's cosine? Adjacent over hypotenuse, right? So
X is like x over 1. So you say that adjacent is x.
the hypotenuse
Is 1. What is the opposite?
by the Pythagorean theorem, that is what? Square root of, yeah, 1 squared minus x squared, which is 1 minus x squared. Right, everybody? Woohoo!
You see? Cosine B is x. So put the x here.
Now,
What is sine B? What's sine B? Yeah, opposite over hypotenuse. But do you see the hypotenuse is 1? So sine B is
the square root of 1 minus x squared. Oh, do you see? Denominator are the same, square root of 2. And then you have the x minus square root of 1 minus x squared.
So this is the answer. By the way, can I distribute the square root and say this is 1 minus x and I cancel the x? Can I do that? No. Okay, so this is square root of subtraction. We cannot distribute the square root. If you have plus or division, then you can distribute the square root. But if you have sum or difference, you cannot distribute. Is that clear, everybody? All right. Yeah, this is what happens when you have inverse functions.
By the way, we don't memorize those formula. By those formula, I mean, what is that? 6.3, the last page. Okay, so I mean this one.
Don't memorize them. No way. Okay? What do? You set that angle, BA or B or theta, and then you draw the triangle. Use the Pythagorean theorem and deduce that. Okay, everybody?
So one method can
help you to solve all these.
All right. So number 5. Okay, number 6. Find all the solutions of the following in the interval 0 to 2 pi. Okay, so here,
This is sum for sine. This is difference for sine.
so we look at the formula. Sine, where is it? Here.
Sine A plus B is sine A cosine B plus cosine A sine B.
Okay, so sine A plus B is sine A cosine B. Sine A cosine B, and then plus or minus, plus cosine A sine B. So this is sine x plus pi over 4. Is that okay, everybody? Sine A minus B is sine A cosine B. Sine A cosine B minus cosine A sine B. Cosine A sine B. So this
guy is sine x minus pi over 4. And then equals
-1. Okay. What's cosine pi over 4? What's that? What's
cosine pi over 4. What's 2 over 2? What's sine pi over 4? What's 2 over 2? Right, everybody?
That's why you gotta be familiar with these values. So, we get sine x root 2 over 2 plus cosine x root 2 over 2 plus sine x root 2 over 2 minus cosine x root 2 over 2 equals -1. Do you see the
Cosine, one is plus, one is minus, they cancel. Right, everybody? And we have two copies of sine x root 2 over 2. Right, everybody? The 2 copy means you gotta use this, multiply by 2.
So 2 copy of sine x root 2 over 2. And that equals -1.
Do you see the 2 and 2 cancel? How great, right, everybody? Aha! We want to isolate the trig function. So isolate the trig function means root 2 over 2, you want to move it to the other side. So both sides, bless you,
Both sides divided by root 2, we get sine x is -1 over root 2. Okay, what is that? Sine. Sine start with 0, right? So this is 2 pi, this is pi, and this is like 1, this is -1. Root, okay, -1 over root 2. This is like the same as negative root 2 over 2. And when do we get root 2 over 2? Wow, that is when we have pi over 4. You see?
So when x is pi over 4, and then here is 3 pi over 4, we get the sine is root 2 over 2. Right, everybody? And when do we have negative root 2 over 2?
Well, negative root 2 over 2 will be, see?
Negative. So it's the same distance but below the x-axis. And then you draw a line.
A horizontal line there. Oh, I see. It's this angle and this angle.
This angle is, look at this. This difference is pi over 4. So this is like pi plus pi over 4. Do you agree? So this angle
this angle is pi plus pi over 4, which is what? 5 pi over 4. Yes, everybody? And how about this angle? You see this distance is pi over 4. Well, this is like 2 pi minus pi over 4. Right, everybody? So 2 pi minus pi over 4. You know, 2 pi is like 8 pi over 4. So therefore, 8 pi minus pi is 7 pi over 4. Therefore, x is 5 pi over 4 or 7 pi over 4. So this is our answer. The problem says find the solution in the interval from 0 to 2 pi. That's why we draw the graph from 0 to 2 pi. And then you can do that. So far, so good? So this is about like solving equation involving trig expressions. In session 7.5, we'll talk about more about this. Okay? So if this is new to you, it's okay. We'll have more examples in session 7.5. Okay. All right. And then number 7. Suppose cosine A is negative 7 over 25 with the angle A in quadrant 3, and sine B is negative 3 over 5 with angle B in quadrant 4. Find each of the following. So this example is similar to this one. Okay, so you first use the sum of difference formula, write down and see what you need. And then you look at the angle and then the trig identities to figure out your these values. Okay, so it's a similar method. Let me think about it. Because it's a similar method, is it okay that you try this at home? Can you do this at home? Can you do that at home? It's a similar method. By the way, we have solution on the website because we are behind schedule, so we're not able to like cover every example in the worksheets. Okay, so I will leave it for you to do it at home. Okay, the solution is on the website. Okay, now we can finally go to 7. Where is it? Oh, 7.3. Yes, 7.3 right here. Woohoo! Okay. So double angle formula and the sum to product or product to sum formula. Okay, so how do we get the double angle formula? Well, this is by, let me close that. Okay, this is by the sum and difference formula. See, double angle formula. If B equals A, then A plus A is 2A. Then it's cosine A times cosine A, which is cosine A squared, minus sine A times sine A, which is sine A squared. So this is how we get the double angle formula for cosine 2A, because this have A plus A. Right, everybody? And now, so we get this formula is from the sum formula of cosine, and let B be equal to A. And then how do we get the next one? Well, we know sine A square is 1 minus cosine A square. And then when you plug in, you get cosine square A minus sine. Sine is 1 minus cosine square. Therefore, is cosine square minus 1. Negative, negative become plus cosine square. So that's why cosine square plus cosine square is 2 cosine square minus 1. That's why we get this formula. Okay? Or if you want to plug in cosine square is 1 minus sine square, and then you get, okay, so plug in here. So cosine square is 1 minus sine square. You get 1 minus sine square minus sine square.
See, cosine square is 1 minus sine square. And minus sine square, you get 1 minus 2 copy of sine square. So all these three formulas, they are equivalent. Okay? But usually, we either use the 2 cosine square minus 1, or we use the 1 minus sine square. Because you only need to know the cosine, and then you can figure it out. Here, you only need to know the sine, you can figure out. You don't need to know both of the sine and cosine. That's why we usually use either this formula or that formula.
Okay, so usually use these two.
Okay, everybody? And then the sine 2a.
Wow, how do we get that?
Sine 2a. See? Look at the same formula for sine. Sine 2a, so a plus a is sine a cosine a plus cosine a sine a. Whoa, they are the same. Two copies. Two copies of sine a cosine a.
That's why we
Get the double angle formula for the sine. Right, everybody?
okay. And similarly for tangent.
Tangent. A plus a. Tangent a plus tangent a. That's two copies of tangent a over 1 minus tangent a. Tangent a. So tangent a squared. Okay, everybody?
Mm-hmm. So that's why we get it forward.
Now, given that sine theta is 8 over 17 and cosine theta is negative, find these following.
Okay, so to relate sine and cosine, use the identity sine squared plus cosine squared equals 1. We know sine, we are looking for cosine. So cosine squared is 1 minus sine squared.
So far, so good, everybody?
Mm-hmm. Yeah, please take notes. And which step you don't understand, ask me. So make sure you understand every step in our in-class example. Right, and then you can do your homework, review your notes. Yes. And visit me during my office hours or email me. Right. Okay, 1 minus sine squared. Sine is 8 over 17 squared. So 1 minus 8 squared over 17 squared. Okay, so 17 squared minus 8 squared, what's that? $225. Oh, you see, cosine theta is then plus or minus square root of 225 over 17 squared. And what's square root of 225? 15. And do you see square root of 17 square? Square root and square cancel. We get 17. And the problem is that cosine is negative. Right, everybody? So the problem is that cosine is negative. So we only pick the negative. Yeah, everybody? Mm-hmm. Okay, we're ready. Now, what is sine 2 theta? Well, sine 2 theta is 2 sine theta cosine theta. Right? We're using the double angle formula for sine 2 theta. So sine theta is 8 over 17. Cosine theta is negative 15 over 17. So the answer is negative. What's your numerator? 2 times 8 times 15. So 2 times 15 is 30. 8 times 30 is 240, right? And what is 17 squared? What's 17 squared? Thank you, 289. Okay, so that's sine 2 theta. Cosine 2 theta. Well, what's cosine 2 theta?
Which formula do you like? Do you like the 2 cosine squared minus 1 or the 1 minus 2 sine squared? Up to you. Which one do you like? The cosine or the sine? The cosine? Okay, so 2 cosine squared minus 1. So 2 cosine squared. So 2 cosine squared minus 1. Oh, gotta be careful, because the minus 1 squared become 1. So 2 times 15 squared over 17 squared minus 1. Okay. You see the denominator is 17 squared, so still 289. And upstairs, you get 2 times 15 squared minus 17 squared. What is that? What is that? 2 times 15 squared minus 17 squared. $161. Thank you. Aha! We get sine, cosine, and how do we get tangent? By the way, do you see? You already get sine 2 theta and cosine 2 theta, and tangent is sine over cosine. We don't need to plug in here. You see, don't need to use that formula. It's longer time, so we can use sine 2 theta over cosine 2 theta. And sine 2 theta, negative 240 over 289 over 161 over 289. Do you see the 289 cancel? Yeah? So we get negative 240 over 161. So far, so good, everybody? Okay. Let's do one more problem. Okay, let's do one more problem. We're trying to catch up, yes. Okay, so here. We want to solve this equation. Do you see this angle is x, but this angle is 2x? When you solve equations involving direct functions, first of all, you want to make the angle equal. You cannot have like something angle x, something angle 2x. So we can change the sine 2x using the double angle formula. That is what? 2 sine x cosine x. Yeah, everybody? See, we use the double angle formula, then we can rewrite it as 2 sine x cosine x. And then, do you see any common factor? 2 cosine. Ooh, what's left? What's left? Yeah, 1 plus sine x equals 0. Yes, our goal, factor as much as we can. And if you see a product of 2 factors equal to 0, then you can set each factor equals 0. So we get, 2 cosine x is 0, or 1 plus sine x is 0. So here is the same as saying cosine x is 0. Here is the same as saying sine x is negative 1. Right, everybody? And now, how do we find x? Okay, that's why be familiar with the sine cosine graph. Cosine, like that. Okay, this is 0, that's 2 pi, that's pi. Oops. What angle gives you cosine x is 0? What's this guy? I'm 2, what's this? Yeah, so pi over 2 and 3 pi over 2. So therefore, x is pi over 2. By the way, if the problem said find the x in the range from 0 to 2 pi, then you say x is pi over 2 or 3 pi over 2. But it doesn't say restrict your x between 0 to 2 pi. Then you have to do
Okay, pi over 2 plus k pi. So here k is an integer.
Because pi over 2, 3 pi over 2, but you can add, because 2 pi periodic. So that's why you can add a multiple of 2 pi, and you can summarize all these into this expression, pi over 2 plus k pi.
Is that okay, everybody? And sine. Okay, how about the sine? Sine. So sine start with 0, right? And this is 2 pi, this is pi. What angle give you -1? Oh, you see, that is 3 pi over 2. So x is 3 pi over 2 plus 2k pi.
Okay, so the period is 2 pi, that's why 2k pi. But when you summarize this together, you realize this solution is actually contained in here. So this expression already includes these ones. Do you see that, everybody?
So that's why when we combine them, we get x is pi over 2 plus k pi. Okay.
Just write this down is enough because these is contained in here. Okay.
All right, let's continue on Wednesday. Have a nice day. And please continue to do your homework. Okay. If you have questions, ask me.